All right, so before we get to the big guns for rational equations, a couple things you got to make sure you have in your toolbox to do these. All right, you need to know how to solve equations by factoring, which for the most part you do. We've been doing a lot of factoring, and this is just setting it equal to zero and solving it, and so you're going to be fine with that. Solving quadratics using the quadratic formula. That's this big, huge equation, which you should recognize from Algebra 1, big formula that gives you the answer automatically, but it's more work than you need to have sometimes. But when all else fails, a quadratic formula never will fail. So you need that. And then you need to understand what extraneous solutions are. Just because you end up with x equals something by the time you're done doesn't actually mean that x equals that something. And that sounds confusing, right? But I'll show you that in a minute too. So let me give you another problem from the rational equation section, and I'll show you why you need this stuff. So here we go. They give us 15 divided by x times x plus 4. Right? And then on the other side, we have x plus 2 divided by x plus 4. All right. So that comes from that problem right there. And I'm just going to go ahead and go big on this screen. Oh, it's much easier for you guys to see. All right. So this is, hopefully you remember what I told you. I think it's a really good idea if you would just cross multiply. That might be one of the easiest things to remember, and it's one of the easiest ways to go. So let's cross multiply. So when you do that, you're going to end up, now, before you cross multiply, I want you to not actually multiply. I just want you to smash it together for right now, okay? So you're going to end up with kind of a long problem, but 15 times x plus 4. Notice I didn't actually multiply it right now. And then on the other side, you're going to have x times the x plus 4, and then times the x plus 2. Okay? And the reason I didn't have you multiply these things is because I want you to look for things that may cancel each other out. Excuse me, guys, if you notice, you see how you have this x plus 4 on this side and you have an x plus 4 on that side. So if you were to do the opposite, if I were to divide by x plus 4 over here, that would just be 1. So in a sense, it cancels out. And over here, if I were to divide by x plus 4, because if you do it on one side, you have to do it on the other, that also cancels out, right? Because it's also 1. So now you end up with 15 equals x times x plus 2. And that's why I didn't want you to actually go through and multiply those. Now you will. So now you're going to go ahead and get x squared plus 2x. And on this side is 15. And this is where solving quadratics by factoring is going to come in. Okay? To factor, you need to have all of these on the same side. So I'm going to go ahead and subtract 15 from both sides. And so now over here is 0. And over here is x squared plus 2x minus 15. And so now you should be able to think to yourself for a second, can this factor out into something? This might be the time where you make your x and you say to yourself, okay, if I were to do this 1 times negative 15, what can I multiply together and get negative 15? But when I add them together, my sum is 2. And you're going to say, oh, that would be 5 and negative 3. 5 times negative 3 is negative 15, and 5 times, and then 5 plus negative 3 is just a positive 2. So that's the one we wanted right there. Excuse me, sorry guys. And then, so let's go ahead and get back to this, and that's going to be x minus 3 and an x plus 5 equals 0. And so when we solve those things, you just set each one equal to 0. You're going to say, well, x minus 3, that equals 0. And x plus 5 equals 0. And so x could be 3, and x could be negative 5. And you would be done just like that. Okay? And then finally, though, but we're not done. We need to check for extraneous solutions. Got to check for extraneous solutions. So you have to go back to the original problem and look and say to yourself, if x equals, so if x equals negative, what did we say? If x equals, oh my goodness. If x equals -5, will that be a problem? And if x equals +3, will that be a problem? The only way it's a problem is if you plug it in for the value and then you end up getting 0 in the denominator. Okay? All right, that's really what extraneous solutions even means. It really just means, and if you're going to take notes, you better write this down. It just means no zeros in the denominator. It's not just that, I'm making it simple for you, but it's really impossible situations. Extraneous it's really just kind of talking about things that are impossible. Impossible things happening. So, for example, if we said that x equals -4, and we were to put that in here, well, -4 plus 4 is 0, and you can't divide by 0, so that's no good. In this case, though, we have x is -5. -5 plus 4 is -1, so -5 would be totally fine. That's good. And it would be fine over here because that's the same thing. If I put 3 in there, 3 plus 4 is 7, that's good. And 3 plus 4 is 7, that's fine. So that would be good too. All right. So we plug those in, they give us real answers, so we don't have to worry about that. So this answer is done. So I should be able to come back to the problem here and plug in our answers of -5 and +3. And they should like them. And they do. And they do. Very good. Very nice. So I'm assigning to you guys practicing solving quadratics by factoring. I will eventually solve quadratics using the quadratic formula. Actually, I assigned that too. And then, and that's that. Then we'll actually get into solving these big problems. All right. If you have any questions, I'll hit me up tomorrow during the live chat or Wednesday or something like that. See you guys later. Bye.